CSWA is just, let me just share my screen. Yeah. I hope the screen is visible. So you may be thinking CSWA is the first step of the CAD journey, and you're absolutely right. SolidWorks Certified Associate is the very, very first step of your SolidWorks certification journey. So it all starts with CSWA, where the most basic things are taught. The more you will come across various things in CSWA, which will help you improve your SolidWorks design. Not just that, but also help you prepare for the next upcoming journey of your SolidWorks certification journey. So this is CSWE, of course, but we are here today, SolidWorks Certified Associate, and yeah, let's dig into it. So I'm not gonna present any fancy presentations, because CSWA is not about presentations, but it's about preparing you for the certified examination. So there are various various tutorials, various things that are available, but all those tutorials won't help you pass the CSWA if you don't know the basic structure or the basic uh, context of the CSWA. So the CSWA exam is the first exam of SolidWorks certification journey, and there are multiple resources available online, even in the SolidWorks website. As you can see here, this is the SolidWorks certification website where the CSWA. I have opened the web page CSWA. So as you can see here, the exam length will be 3 hours. So you have maximum of 180 minutes, and the passing grade is 70%. As you can see here, there are multiple tools, features that you need to know to pass the CSWA. So it's not how you design or what you design, it's what tools, what features you know in SolidWorks. As you can see here, there are multiple things: sketch entities, sketch tools, basic things, and then sketch relations, boss and extrude, fillets, linear circular dimensions, and then dimensionings, feature conditions, start and end, mass properties, materials. And these are the basic things that one needs to know to pass the CSWA exam. And the thing is, there's a sample exam available on the line. You can either download the zip file where there will be part some parts basically like this, which helps you to come up solve the the sample exam. So now I'm gonna teach you the tips and tricks through the sample exam. So this will be kind of a hands-on session. So I will take you through this complete CSWA guide, and then I'll even show what you need, how the sample exam looks, and how you can know various things during solving this sample exam. So let's begin. So yeah, this is the guide of, this is just the sample exam PDF from SolidWorks themselves. So this just shows how to prepare for SolidWorks and what are other certification exams. So CSWA is the first step. There are multiple divisions in CSWA, like mechanical design, simulation, electrical, additive manufacturing, and each of these has its own separate learning modules. And today we are going to discuss about mechanical design. And once you do CSWA, so you can write CSWP without CSWA, because CSWP do not have any kind of eligibility criteria, unlike CSWE. But the thing is, if you directly come to CSWP without knowing how the exam will be, it will be a little difficult to finish the exam within the specified time. You may be able to solve all the, but the thing is, the error percentage is very, very high in SWA and P. It's about 0.5%. So your answer has to vary within that percentage. So you have to be very careful when you're designing or editing something. So it's always better to take CSWA first and then CSWP. After that, there is CSWA, which is Certified SolidWorks Professional Advanced. There are 5 modules: sheet metal, weldment, surfacing, mold tools, and then drawing tools. You have to pass. So to attend CSWE, you have to pass CSWP and 4 out of 5 of these exams in CSWP. Only then you will be eligible for Certified SolidWorks Expert examination. So that is the criteria for CSWE. CSWA is not a criteria, but the thing is, it will give you the basic idea, basic structure of the overall SolidWorks certification examinations, how it will be, what kind of questions will be asked, and etc. Trust me, CSWA will be very simple, and it will really help you all to go to the next level of certification exam. As you can see here, this is the exam detail. So there will be basic part creation and modifications. This is very crucial. Many will be able to create the part, but when it comes to modification, they hesitate a little. They create new parts again, and then they start the exam again. So that's not how usually it's done. I'll show you in the coming session. So this is just some Q&A. There'll be 3 questions. Each will carry 5 points, and then you have 2 questions for part creation and modification, and again 2 questions on intermediate parts. So both are not the same. Both will be different, but the thing is, the idea is same. You have to create a part and then modify it as per the given dimension. And then again, advanced part creation and modification. This will be little difficult than the first two. As you can see here, there's only sketching, extrude, and modification is used. Here there is revolve, but in this, everything is used. It's not just extrude and then dimension change. It's extrude, cut, even revolve will come sometimes. So you have to know these tools to design quickly in the given time. And then last is the assembly, which is the simplest and the easiest one of all. So there will be overall 14 questions and 240 marks. You need minimum 165 marks to pass the exam, which is 70%. So these are some of the tools. I'll just go to these links. So as you can see here, this is the forum, SolidWorks forum. You can ask any questions, anything. There will be this is the SolidWorks forum, my bad. So yeah, so you can ask if you have any doubts on the structure of the exam, but you cannot ask exam questions in the forum. There will be materials available, the ones which are here at the moment, the sample exams. And the next is mysolidworks.com. So if you have SolidWorks key with you, it can be student edition as well. You can log in, enter your student edition code, and then you will get the CSWA preparation course and CSWB preparation course, which you can use to pass the exams. But this is not available for everyone. If and only if you have a SolidWorks key, you can view these things. So I'll just go to the practice questions. And one more thing is, before I start the practice questions, these real-time exams, practice exams, are also available in SolidWorks Virtual Tester. So all you have to do is download this virtual tester. I'll just drop the link in the chat. All you have to do is download this virtual tester and go to the SolidWorks Associate preparation exam. So that's it. Then you'll be able to take the same exam that I'm going to show you today and check how fast you can design. So without further ado, let's jump to the questions. Okay, there's a lot of this, my bad. Yeah, so as you saw before in the previous slide, the first will be the questions. There will be 3 questions for 5 marks. See, these are some sample questions, and this is the start of the sample exam, as you can see here. And yeah, anybody here knows what drafting is? Or the question says, to create a drafting view B, it is necessary to sketch a spline on the drawing view A and insert which SolidWorks view type. Okay, so if you know SolidWorks only, then it will be helpful. Since I'm starting from the scratch, I'm going to skip this. I'm going to come back to these questions, and then I will, after finishing all the part 2 and part 3, I'll come back to that, show you the drawing tools as well, and then we can start. So yeah, coming to the first part, as you can see here, this is how the exam module will be. So this is the first part, which says the following images are to be used to answer questions 3 and 4. So this is the exam. They will give each and every dimension, but you have to observe that you can see there are 3 variables, two variables, A and B. So these 2 variables will change as per the module. For changing purpose, these 2 variables will change, A and B. Okay, there is a C as well. Where is C? Oh yeah, here is C. There are 3 variables which will change. You have to keep this in mind. So as you can see here, the part is build this part in SolidWorks. Use the system MMGS decimal 2, and all these are the things, details like material, density, and ABC values. These are all things you should know. So how do we start? This is very simple. So as you can see here, the basic structure is like this. I'm going to just draw that in SolidWorks. You go to front plane, and then 1 minute. So before we start, like most of you might think, okay, first we have to draw the circle and then line, give the dimension, and then angle, give the dimensions again. So that's one way, but it is time consuming, right? We don't want that. So there is one more easier way. I'm going to show how to do that. It's very simple. So first is we'll take line and then start drawing the basic structure of the given part. As you can see here, it's like this, and then there's a line, and then there's a curve. So we'll just leave the curve, since it has a curve like this. What you can do is you can just press A here, and it changes to the curve side. You can see here, this is a curve now. And then again switch back, and then it goes to line, and another 45-degree, and like this. And again, it goes to curve. So to switch from line to curve, you have to just press A, and then you have a curve. We can change the dimensions later, and then a line. So this line is horizontal, so we'll give the relation as horizontal, right? So this is the basic thing, basic structure of the given drawing. And now the second step is to give the dimensions. So we'll start with the dimensions, 32, and overall is 8. So this is 32. And how do we give this A? So since A is a variable, we have to set it as a global equation. And how do we do that? Just select these two lines, and then when you're entering the variable, select the equal sign and then type A. So now when you click on this particular thing, it assigns this particular value to the equation A. Okay. So when you click on this, now as you can see, there's a symbol sigma, which means this equation is now, this dimension is now an equation. And how do we know that this is an equation? As you can see in the equation tab, if you drop it down, there is a variable A, which says the value is 74.74. You can edit that here by double clicking the dimension. The A variable is 81. So we'll assign A as 81. You can either create the variables like this, or you can go to the equations. Before that, I need to exit the sketch. You can go to this equation, right click, manage equations, and then type the equation B. The value is 57. And another equation C, whose value is 43. 43. That's how you create equations. This is the very crucial step of your first design to make sure that you can edit the design later. And now when we go back to the sketch, you can either do it before starting the sketch or during the sketch, but you have to exit the sketch or give the dimensions inside the sketch like I did. And then next is B, which is 57. So we will assign it as B equals B. So you have to put this equal. Otherwise, what will happen is when you just put B here, what happens is it just assigns the value to 57. The dimension is not connected to the equations. To make sure the dimension is connected to the equation, you have to put equal sign before assigning the dimension. Only then it will be valid. And then, okay, I'll start with this. The radius is 29. 29. See, okay, we'll come to this later because there's a very weird thing happening. That's because there is no relation. This is 19. I just give that. And the next is there's a 10-degree line here. So our curve is not exactly the curve we want. We should drop to 10 degree, and then the curve starts. So what we'll do is we'll just draw a small line and then take this arc and leave it at that. Make sure, see, as you can see here, there is a tangent direction, which means this line and the curve is tangent to each other. So we will just add the relation, shift select two lines, the arc and the line, and then assign tangent here. And the angle between this line and this is 10 degrees. So 10 minus 180 is 170 degree, right? And this dimension is, I'm sorry, before that, this is 14, this is 13, and this is 7. So this, the vertical length is 7. And see, if I give another dimension here, it will not be connected. So what we should do is, since both of these are same, as you can see here, this is 7, this is 7. What we should do is put equal sign and then click the dimension. You don't have to put 7. So now this dimension is now connected to the previous dimension. So if I change it to 8, as you can see here, if I change it to 8, the below dimension automatically changes to 8. So I don't have to do anything. Let's go back. And the angle that they're given is this, and this is 45, right? 45. And we'll do the same for this as well. Okay, no need, because that's already in 45 degree angle, as you can see here. But if it is not, you need to manually do it. And the next is, okay, this is 29. As you can see here, the distance from this point to this is 29. And this is 5, right? You can either give the dimension like this, or what you can do is you can do like this and then add a chamfer, which is of 5 mm. Since it's a 45 degree angle, it will be 5 and 5 in both the sides. So as you can see here, this is 5 and 5. And the next is, this is 29, which is 29, the point and the line. We'll do the same, the point and the line, 29. And this is 24, which is the point and the line, 24. And this is 14, the point of this horizontal line and the vertical line is 14. And then 10 degree, we have already done it. And this is R19. But how do we do it? All you have to do is just click on this, and then it says 19. That's it. Since it already has a relation, that is, it's tangential to this, you don't have to give the dimension to the center. But for this, we need to, because this is not horizontal or anything. So what we're going to do is, as you can see here, the center of the arc is coincident with this line. So what we're going to do is, we're going to take this point and select the line and click on coincident. Okay, there's some error. What I'm going to do is delete this. Okay, I'm going to take the 3-point edge again. Yeah. So now I'm going to take the center of the arc and hold shift, select the line, and then I'm going to click on coincident. Now it's coincident, and the distance from horizontal line at the bottom is 19. So we'll give the dimension 19. And the last thing is, there is an R29 on the curve. So that is the dimension of the curve, which is 29 mm. You have to make sure that you're in MMGS. Do not forget this. If you are in any other format, please change it to MMGS. Otherwise, you will not get the same value. And the last step is R5. So to do this, all you have to do is just go to the fillet here, sketch fillet, enter the value as 5, select the corner. Voila, that's it. So now our basic structure is ready apart from the horizontal cutout. So we'll do that. Select this circle from center point and then draw it. Give it a dimension of 14 mm. That's what the dimension is, 14 mm. And this circle is at a distance of 14 mm from horizontal line and 14 mm from vertical line. So both are 14 and 14. So what you should do is select the point, select the center point, select the bottom, and which is 14 now. Yes. And do the same for the vertical line as well. So now, as you can see here, the basic drawing is now ready. You have to make sure that you start from the origin. What happens is when you don't start from the origin, your entire sketch will not be fully defined. As you can see here, everything is black. The lines are black. But if I select this point and then remove the coincident, what happens is my sketch is not defined, fully defined now. All the sketch have dimension with respect to each other, but now it is not completely defined in the space. You have to make sure your sketch is completely defined. Only then the changes you make will be perfectly fit. So what you should do is, if you do like this, you can select any point, and then select the origin, and then click on coincident. That's it. That's the only thing to make sure your sketches are coincident. I'm going to exit this sketch now. As you can see here, this is still 2D. And this last dimension is C. And we have not applied in any of the drawing here. So now I will apply it. Go to extrude. Extrude. And then here, similarly, you have to put equals, global variables, and then C. That's it. Because we have already assigned the variable as C here. Now, this complete model is in variation with the equations. So that's it. That's only one step. So only with one feature, you can create this entire part model, right? We did not use anything, only sketch and extrude. That's it. Now, the next step is what's the overall mass. As you can see, they have given the material as AISI 1020. So we'll go to the material section, right click, edit material. Instead of going through all this option, just enter AISI 1020 in the search bar, AISI 1020. But is it steel cold rolled or normal steel? So it is just steel, right? They haven't specified if it is cold rolled. So now select this, and how to make sure it's not cold rolled. They have also given density. As you can see here, the density is 0.0079 gram per mm cube. So check if the density is the same as density, mass density. Yeah, we'll change this from, okay, 0. It is 0.0079 kg per centimeter cube. So 0.0079, it's gram. So gram and centimeter, they both cancel out. So you will get the same value, 00. So this is your mass density. If you change this to kg to mm cube, then it will be different. Since it's kg to centimeter cube, it's the same. No need to worry about it. Apply this material and then close the tab. And to measure the overall mass, go to the evaluate tab, press on mass properties, just to be sure, recalculate it. And as you can see here, the mass is 939.54 grams. Let's see if we have that in the option. Yes, as you can see here, the overall mass, okay, if you don't find an option within 1% of your answer, please recheck your part. Basically, you have 1% error rate in CSWA. So your answer has to be, whatever the answer you get here has to be close to one of the options. Now we got 939.54 and we have the option here. So that is the answer for your first question. So you have to make sure you are entering all these dimensions properly. Even if I'll just change one of the dimension to show the error. Let's say instead of 14, I'll make this 50. Okay. So what happens now is, instead of 14, my hole is 15. So there is a material removal. So my overall mass of the model will be less than 939. See, as you can see here, the mass is now 931.80 with just 1 mm variation. But this is still closer to 939. This will not be detected now. But the thing is, my error is already at 1%. It's not exactly 1%, which is 9.31 grams, but the error is almost 8 grams or something like that, because we had 939 and it changed to 931. So I am almost at the border, which is not a good thing, because when you change, even when you make changes to the model, the error is going to increase by whatsoever the percentage as depending upon the equations. So make sure your answer is almost or exactly the same, as in you will not know in the exam, but this is how you prepare for the exam, right? So make sure you have entered all the dimensions correctly in the sketch. Sorry, all the dimensions correctly in the sketch and the extrude command, because even with one mm error, you're gonna get 1% gram variation. So remember that. Now we have changed to 14 again, and let's save this model as part one. Now this is our part one. The answer is 939.54 grams. We already got that. Now the second question is completely dependent on the first question. It's not different. So in second questions, as you can see here, what they're telling is modify the part in SolidWorks. So the drawing remains the same. All you have to do is just change the A, B, C values. That's it. You don't have to do anything. So the material is same. We can verify that by checking the density. So let's change the equations in this equation tab. Manage equations, change the A value from 81 to 84 and B value from 57 to 59. And C value is 43 to 45. That's it. Now, once you change this, okay, now it has changed, and you can check the mass. The mass, it says 1032.32 grams. 1032.32. Let's see if that's in the option. Okay, okay, my bad. In the second question, there will not be options to check. So you have to manually enter it. So the second answer is 1032.32 grams. We can verify it at the end where there is an answer sheet. Let's just take a look. As you can see here, the answer is 1032.32 grams. That's the one which we have gotten. So now that's your second question. And there will be another third question. Again, it says part modeling continued. As you can see here, it's a little complex. It's not a simple one. There are cuts, there are revolved cuts, multiple things are happening. You can see multiple holes here. So you have to make all of this. And then there is a shell thickness again. So it's not as easy as you think it is. So you have to be prepared for it. So I'm going to show you how to do it. So as you can see here, there's a modify this part. Everything is same. The material, the density is same. What's changing is the part itself, right? Now only one pocket on the side is to be added, note one. So as you can, from the diagram, you can see there's a pocket kind of thing here. And it says only one pocket on one side is to be added. This modified part is not symmetrical. So as you can see here, it's not symmetrical. If I draw a line here, the top half and the bottom half is completely different. So both are not symmetrical, the two halves. And the second is assume all unspecified dimensions are the same as in previous question. The previous question is question 2, not question 1. So they have not specified the questions. They have not specified the values. Oh, my bad. They have specified the values. Oh, I jumped the question. My bad. So this is the third question. As you can see here, there are different cuts. So we have to make this. And the ABC value is also changed. ABC value is 86, 58, and 44. And yeah, this is the fourth question. 1 minute. Yeah, this is 4. We have already done it. And this is the fifth question. In the fifth question, the ABC value is 86, 58, 44. Let's do that first. Now we are jumping to the third question of the same type. Now, before you make any changes to the model, change the equation, which is 86 and 58 and 44. It's not that big of a change, but still these changes give a lot of errors if you don't do it. And the next step is, as you can see here, there is a cut here. From the top view, it is at a depth of 19 mm. And from the front view, from the other side, there's a 52 mm. So we have to make sure this region is A minus 52, right? If this is 52 and this is A, this remaining section is A minus 52. Let's do that. Go to, you can go to the front side plane itself because they are not symmetrical, right? See, this cut is on this side. So since they are not symmetrical, you can choose, instead of choosing the front plane, you can choose this. And also, how do we sketch this again? Because the sketch is somewhere here, and then this says the cut is like this. We cannot sit and sketch again, right? So what you should do is go to convert entities and then select the face which you want to trace. When you select this and then right click here, what happens is it traces the outline of the selected face. It's very simple, right? It just selects the face, creates the outline, and all you have to do is now select a line from this to this, right? And give the dimension 52 from the other end. As you can see here, this dimension is 52. And the lines on the other side are unnecessary. As you can see here, this area remains the same, and only this area is being cut. So you can go to the trim tool and trim all the other lines, right? That's it. My bad. Dimension also went away. So yeah, this is now 52. That's because I took the line as a reference, not the edge. So once you delete the line, give the dimension again, you have now this line, this area, which has to be cut at a depth of 19 mm. So let's do that. Features, extruded cut, and let's cut it for 19 mm. Now, first modification is done. As you can see here, this is not symmetrical. And the second modification is cutting it. See, as you can see in this isometric view, it is being cut at a curved line, right? So if I go down, there's this sectional view. Yeah, there's a sectional view, and it says the radius of curvature is 41, and the height of this edge, the curve edge, the other edge is 36 mm, and the center of curve is horizontal to this edge. So these are the observations you have to make when you're solving the questions. It's not just about just putting the random dimension. It's also about how observant you are, how you are observing the entire sketch. So now if you just put R41, this curve as 41 and then at a 36 mm, it will not give the exact curve. So to make sure that you're getting the exact curve as the drawing, this center of curvature has to be horizontal to this edge. Let's do that. And before we do that, see, as you can see here, there is a 12 mm depth from the other side, and then they have given 24. So this remaining edge is C minus 24 minus 12, right? So obviously this is the center plane and it's not symmetrical. So what we should do is we'll sketch it on the other side or this side. We can sketch it on any side. I'll just use this. I'll sketch here, and I'll just show what to do. So now we'll take 3-point curve. Oh. Select this line, and next is the line. See, the curve is on this curve, and the second point is on this line. And next, just drop it anywhere. After that, you have to make sure this center of curvature, center of the curve is horizontal to this line, or this center of curve is horizontal to this particular point, right? When you click both the points by holding shift, you'll get these options. Select vertical, not horizontal, my bad, vertical. After that, give the curve a dimension 41. And the last thing is 36, the edge point to the horizontal line from here to here, which is 36, right? 36. So as you can see here, the curve is now completely defined. And to make sure you can cut the entire thing, what you have to do is select this face, click on convert entities, and trim the unwanted areas, because we don't want this to be cut. We only want that section to be cut. You want this section only, not this section. So instead of drawing it manually, you can use convert entities. Click OK, exit the sketch. Yeah, as you can see here, they have given 12 mm offset from the other side and 24 mm of cut, but they have not given this side. So as we know, C is nothing but 44. So this remaining section will be 44 minus 24 minus 12. Now what we'll do is we'll just go to select the sketch, cut. Now when I select cut from sketch plane, it just directly cuts. I don't want that to happen. We need an offset of C minus 24 minus 12. So what we should do is go to this drag down option from option. And then as you can see here, there are multiple options: sketch planes, surface, vertex, and offset. Offset is the one we want. Click on offset, and the offset is C minus C. I'm selecting it from global variable. That's why I've put the equal sign. C minus 24 minus 12. Just a minute. Yeah. So now it's in the other direction. So we just have to flip this. Now it is in the proper direction, right? As you can see here, this distance is now C minus 24 minus 12. And we want it to cut for 24 mm. So in this region, select 24. That's it. Cut it, and your model is now ready. But how do we make sure if it's right or wrong? They have given 12 here, right? The edge length is 12. If you go to measure, evaluate, click on measure, and select this edge. If it gives 12 mm, then our math was right. So we gave the offset C minus 24 minus 12, cut it for 24 mm, and our entire model is now done. Or not entirely done. There is one more step that has to be done, which is, I may have missed a step. So let's go back here to the sketch, edit it. What I missed was I selected this region, but in the drawing, what I missed was the bottom region was also cut, as you can see here in this isometric drawing. As you can see here, the line, the horizontal line, below that, everything is cut for a depth of 15 mm. Depth of 19 mm, my bad. So we'll just replicate that. How do we do that? Select a line, and it starts from here and ends here. And how do we know if it's the same line or not? Measure this thing. It says it's 19 mm. Or what you can do is instead of I'll just take a line and end it here. Make sure the dimension is 19 mm from the bottom. It's 19 mm. And go to convert entities. I only need these edges. I don't need the entire edge, right? Because I need to replicate this region. So what I can do is, instead of selecting the face, I can manually select these edges. See, I'm manually selecting the edges. And now click OK. Now I just need to make sure this is coincident. And this is an unwanted region. So just trim it. As you can see here, now we have the necessary cut. I had forgotten this, but now that I see there is a cut, but since we cannot again click on this convert entities, and trimming everything is just too much of work, what you can do is you can click on convert entities and only select the necessary edges to convert that particular edge line to a sketch line. Now, if I click exit, my model is now ready. As you can see here, it's almost ready. One last thing is the cut, the circular cut, which is of 11 mm diameter and at a distance of 14 mm horizontally and 14 mm vertically. We'll just do that. Select this plane, click sketch, circle. We'll first give the dimension from horizontal line, which is 14, and give the horizontal vertical line distance, which is again 14. Next, the dimension of the circle itself, which is 11. Yeah. Now, this has to be cut throughout the model. As you can see here, it's throughout the model. It's not up to a point or anything. So when you go to the cut feature, instead of giving the dimension, what you can do is drop this option of blind. And here there's an option called through all. Just select that and the sketch cuts throughout the model. So you don't have to worry about making changes or selecting the dimension or giving it a dimension. Now, our third question is completely ready now. As you can see here, it's 19, it's C, and then we have done this as well. And what's the overall mass of the part? Now we'll go to evaluate again, mass properties. Then it's just recalculate to be sure. It's 628.18 grams. Now, how do we know if it's true or not? From the answer key, which is 628.18 grams. So if you do every step properly, you will get the answer right. But if there is an error in your first question, then that error will lead to multiple errors in the second question. So it's like the square root of 0.1, 0.9 and 1.1. It may not make that much of a difference, but as you progress in the questions, the error will lead to the square root of the errors. So your error will gets bigger and bigger. So your answer will become your answer will be away from the actual answer as you move on to the question. So make sure you do not make any error in the first question, because you can verify that in the first question there will be options. You don't have to enter. There will be ABCD options, and then you can make sure that your answer is exactly the same or not. If you do not get an exact answer, go back to the sketch, make all the check if everything is right, and then come back. If it is like 939.5352, that is fine, because that happens. But if your answer is like 934 instead of 939 or 931 instead of 939, make sure you go back to the sketch and then check everything again. If the error is after the decimal point, I don't think you need to worry much. And we have done this, and going back to the next question, which is this. As you can see here, there is multiple shells, and then they have given one tip. That means the thickness of the shell is 1 mm. You have to make sure the thickness remains the same. And then this thickness ends at 12 mm, right? It's not like you're cutting the entire thing, but there's a thickness. As you can see here, there's a thin wall of 1 mm. You have to maintain that. And your ABCD value remains the same. As you can see, they've given, use the part created in the previous question and modify it by adding a pocket. That's all you need to do. Only one pocket on one side, it will be added. It's not symmetrical, and assume all unspecified dimensions are the same as in previous questions. So our ABC values remains the same. No need to change the ABC again. And material and density remains the same. So no need to change that as well. Next, let's do the this thing, pocket. Before that, I'll go, okay, we need to create a pocket here, right? So how do we do it? Very simple, trust me. All you need to do is click on this, select sketch, and then we need to create a pocket on the inside. Now we got to know about the convert entities tool, but there's another tool called as offset entities. What this does is, if you select this and then click on any line, it creates an offset. As you can see, the yellow thing is depicting the offset of 1 mm. But you can, instead of selecting the edge, if you select the face, it creates the offset around the entire face. See, it's that simple. You don't need to worry about creating the offset, right? See, as you can see here, it is already creating an offset. Since we don't need this particular part, we need the offset in this region, right? So check on offset, select this particular face, and the offset is currently on the outside, but we want the offset to be on the inside. As you can see here, the thickness is on the inside. So what you should do is select this reverse direction, and click enter. Your offset is now ready. And this offset is not there near the circular region. As you can see here, the offset is not there because there is no thickness around this circular region. So now all you need to do is make sure this offset is ending before 1 mm. Before we go to the extrusion, the length of this particular edge is 8 mm. So we need to cut it for 7 mm only, right? So select the sketch, click on the extrude. Instead of through all, go to blind, put 7. If you don't know how to measure this, what you can do is, instead of here, you can give an offset afterwards, but that's a risky thing. So what you should do is measure this particular line. I'll just do that again. Go to evaluate, measure, and then measure the line. and the length of the line is 8 mm. As you can see here, there's a thickness of 1 mm. So all you need to do is go back, extrude cut, select the sketch, and then give me a minute, blind cut it for 7 mm. That's one step. Now the second step is to cut the inner region. Now to cut the inner region, you need another offset from the inside of this curve. But how do we get it? Again, it's very simple, trust me. So now go to the sketch, right? And then we have already given the offset here, right? So we don't need to give the offset again, but we need to give the offset from the curved edge, from this side. So we are already in the sketch of this plane. What you need to do is select this, convert entities. Just a minute. Okay, so go to convert entities, click on the edge of this thing, right? Now, when you click on that edge, now this edge is being replicated on the sketch plane of your choice. As you can see here, we have replicated this edge onto the plane. Now select this, click on convert construction geometry, and we need this region and offset it for 1 mm because that's the given dimension, right? As you can see here, this is at an offset of 1 mm. See, they have given it here, and you can also see it here. This is at an offset of 1 mm. So I have done the same, and go to convert entities, select all these things. I've added. And go to trim entities and select the unwanted lines. These are all unwanted lines. Now we have another region ready to be cut. So convert entities works in either way. You don't need to select the faces that are visible. You can also select the faces or edges which are behind your model, like this edge, or I could have even selected this edge, even this edge. So anything. What it does is it creates a silhouette of that particular edge onto your sketch plane. So that's how the convert entities works. Now select this particular thing, and it says there is an offset of 12 mm. And we know that the edge length of this is 12 mm, right? We'll go to measure bar, measure, evaluate, measure. See, this edge length is already 12 mm. So the cut from the sketch cut has to start from this plane and end till this plane. But how do you know what's the distance between this? It's a little difficult to measure as well, right? So what you can do is in in features, there's an option inside extruded cut. So go to this, select this sketch and click on the extruded cut. Instead of blind, select the surface, up to surface option, and click on this surface. See, as you can see here, the cut happens only till that surface. You don't need to worry about giving the dimension or anything because we already know the edge length is 12 mm. If and only if you are certain, you have to choose this option. Otherwise, what you can do is, before cutting, what you can do is go to the measure option and select this face and select this face to check what the distance. Now it says the distance is 25 mm. Now what you can do is you can remember that and then give the dimension in the cut extrude. So you can either choose one or the other option, but you have to make sure the distance from this plane to this plane is 12 mm. But how do we make sure if it's in the same range? Go to measure, select the inside face and select the outside face. It says distance is 12 mm. And as given in the question, the distance is now 12 mm. So our method was right. Now, since all the materials and everything is same, we can directly jump to the mass measurement, which says the mass measurement is 432.58 grams. Let's see if it is correct or not. As you can see here, 432.58 grams. See, it is exact to the model. So if your model is same, like if you have done everything as per your, as per the model or the dimension that's given in the questions, your answer will be absolutely perfect. You don't need to worry about anything. And I just need to show you guys one more feature. So in in CSWA,
Sir, I have a question for this.
oh yeah, hi, yeah, please go on.
Sir, if there any problem if I made this pocket with using the shell,
Yeah.
which kind of problem?
Okay, you are asking, can you use shell option here, right?
Yes, yes, yes,
Yeah,
yes, yes.
I'll just show what happens. So now what they have told in the question is, why I didn't use shell is because, see, as you can see here, in the question they have said you have to create a shell only in this region, not in the entire model. Remember this section diagram. I'll just use the shell and then show you what happens. I'll go to shell. I'll click on 1 mm, select this shell inverts preview. Right? I click on the shell. Now what happens is it will create the shell around the entire structure of this. It's not just one side or one region, right? It creates shell everywhere. So my mass will be very different from the previous answer. As you can see here, the mass will be around 121 grams. Then 121 grams is nowhere in the option. It's impossible. See, the section is like this. If I go to the section view of the current shell part from top, see, this is how the section view is. Everywhere there's a shell, but I don't want the shell everywhere. I only want the shell in this region, right? So if you use shell, you will definitely get a wrong answer. I mean, in this question. But if they had mentioned the shell is everywhere, we could have used shell. Since it's not the case, we have to use cut extrude for this option. I'll just suppress the shell and drag this down. See, as you can see here, this is how it looks. And it is equal to that shown in the diagram. See, this is solid. That is why it's hashed in the diagram. But if I use shell, that's not the case. Using shell will lead to shell everywhere. See, even in isometric view, that's not the view. See, even in isometric view, you cannot see the shell everywhere because the shell does not exist everywhere. So this is one section view which they have shown, the U section. From U section, you can understand that this shell exists only in a particular region. So by using shell, you're creating the shell in unwanted regions as well. So make sure you see the drawing before you operate the commands. If it's not everywhere, if you know how to use shell command by splitting the objects, that's totally fine. But for CSWA level, they will not ask that complicated stuff. You can use shell, but you have to cut the object into multiple parts by using solid surfaces, which is not a CSWA level question. So make sure you just use cut extrude if they ask similar questions. Did that answer the question?
Yes, sir. Thank you very much.
So yeah, this is the first part. Before I end the first part, there is one more thing that I need to show you. So there will be only two questions, so you'll have three parts to model in CSWA. But since it's a practice thing, they have given four. But in reality, you'll only have first creating the model and changing the dimension. Second question, creating the model. Third question, changing dimensions like this. So make sure you do all the things like this. And then one more thing that I have to say is they sometimes they will ask, okay, maybe not in CSW. Let me check the syllabus again. Going back. Yeah. Yeah. Okay. The syllabus is, see, sketching, extrude boss, extrude cut, modification key, which we have covered already. Sketching, revolved boss, extruded cut, and circular pattern. Okay. So circular pattern is something which I'm going to show it with a different example. So let's say you have a base here. And then you have a feature in the base. Let's say it's like this. And now what they will ask is they will ask you to create this circular thing for 12 rounds around this particular, particular face. So if you go to sketch, give the dimensions again, like, 360 by 12, draw another circle, give the dimension 360 by 12, draw another dimension. It's time consuming, right? So what you can do is you can use circular pattern to create this particular feature around this body. What you need to do is give the direction, like here in this particular option, you need to select an axis or a circular or cylindrical face. So this is the cylindrical face. I want four patterns of this particular feature around this. As you can see here, now it creates four features of 4 or 12. I can increase it as much as I want. So it creates a circular pattern around this body. So that's what circular pattern does. I don't think in CSWA, but yeah, there may be a big possibility of asking this question in CSWA. But this is just for your reference how this sketch pattern works. And I'm gonna exit that. So yeah, next is again in advanced, it's sketch offset, which we had done it, extrude boss, extrude cut, modification key, and more difficult geometry modification. More difficulty geometric modification was that shell thing that we did. And we have covered the entire basic sketch thing and then model thing. Make sure you do maximum practice. You can find all the practice drawings in Google. If you just Google practice models, you will find lots of models. You can do that. And coming to the assembly carries only one part of your entire thing. But what they will ask is, I'll go back to the assembly question. Okay, now it says this image is to be used to answer question 7 to 8. This is how the question is. And they have variables A, B, C, even in the assembly questions. Now we have to use just basic mates here. We don't need to worry about advanced mates in CSWA. Advanced mates comes only in CSWP. So for CSWA, all you need to know is basic mates. Now the seventh question is build this assembly in SolidWorks chain link assembly. Okay, I have already downloaded the attached zip file and I've already saved the component. And do you want to proceed with? No, that's all fine. Now the question says pins are mated concentric to the chain holes. Pins are mated concentric to the chain holes. These are chain holes. And another thing what they're saying is pin end faces are coincident to the chain link side face, which is nothing but the top of the green is coincident to the top of this particular chain link face. That's all it says. And this particular thing, the blue thing has to be coincident with the horizontal face of the yellow thing. Now, how do we do this? So you will get everything in this particular website. I'll just share this link. The parts are available in the shared link. You can go to that, download this particular, click on the sample exam zip, it will automatically download. So I'm sorry for the disturbance. Let me just open assembly and I'll start importing everything one by one. Assembly, insert components, the basic things, right? Like we need to import chain, long pin, short pin. But before we import all the component, I'll just import long pin. Okay. Oh, I don't think it doesn't matter how it looks. So I'll just place it here. And the question says pins are mated. Okay. And as you can see in the image, the origin is at the center of this particular pin. You don't need to worry about that because I'm going to show you how to create a copy origin. So don't worry about this because it's impossible to mate it exactly like that. It takes like multiple tries. So I'm going to show you how to create that. But before we do that, now whenever you import a first part into the assembly, it is fixed. Let it be fixed. You don't need to change that. Let's start importing the other component, which is long. Okay, chain link and short pin. Import both of these. Okay. You can rotate the model by using these options here, right? Now in the option, it shows like this. So we're gonna rotate it like this. And no, not okay. We need to rotate it around x-axis. So using this option, you can orient your particular part however you want. Okay. Now this pin has to be revolved around x-axis. That's it. Done. Now the next step is mates. Now they say the link has to be concentric to the long pin, which is automatic. If you select the, as you can see here, I'm sorry, I forgot to show that. If you just select the cylindrical component and then cylindrical component of different parts, it automatically goes to concentric. Right click on it. And then it says it has to be coincident for the top and the top face. So now, now it has to be coincident with this face to this face. Done. And in the second point, it says, see, there are three components, only three, but you see multiple things that you don't have to worry about that. And then the second says pin end faces are coincident to the chain link side faces. So that's something, but first you need to make this and this concentric and this coincident. It automatically does it. You don't need to worry about that. Now we have done this, but how do we create the rest of the models, right? Since all these yellow parts are same, as you can see here, the yellow parts here are one and the same. What you can do is you can, instead of importing the parts again, you can use a shortcut called copy with mates. Okay. Click on copy with mates, select the first and second. No need to select this. Select the yellow component. You need to copy it for 1, 2, 3 times. So click next. Again, it will ask concentric. This particular face, this particular cylindrical face is now coincident, has to be coincident with this, because that's how they are arranged. And the next coincident is this. Okay. So instead of the top face, you need to select the inside face. And just vary that. You just need to use this directional lines, directional arrow marks to make sure they're aligned properly. If you go through the model and then start doing it, you will come across how to do it. But basically the thing is, you are replicating the mates. Instead of providing the basic mates, you're just selecting the different faces on the other object to make sure your object is now mated. I'll just end it here and click exit to show you how it works. See, now it is mated properly, right? Similarly, you need to create 2 more copies. And how do we do it? Again, copy with mates option. Copy with mates. You can either search for the option in the command, or you can just search for the command in this option. If you search copy with mates, it automatically shows up. Or I'm going to add it as a shortcut. Copy with mates. Right. Click on copy with mates. Select the same component again and go to the next option. Select the concentric. Instead of this face, now concentric is your purple face in the new object has to be this. If they don't, okay, now as you can see here, it's now completely perfectly aligned. Now next, click on OK, and then again do the same for the another component. The concentric will be this, and the new purple face from this object will be this. Done. Now when you're done, click exit. Now your chain link is ready. And at the end of the chain link, there is another green line. Either you can insert component or again go with copy with mates. Go to copy with mates, select the green component, go to next, select this concentric to be. Okay, before that, I'm going to create equations, manage equations. A, the value of A is 25 degrees. And B, the value of B is 125 degrees. And C is 130. So that's done. So we'll first apply the mates, angle mates, and then we'll move on to the next step. So angle mates is nothing but it just makes, it just gives a proper angle between the faces. Now in the first diagram, as we can see here, it says angle between the horizontal of first link and the second link is A. So we'll go to angle mates. Instead of 30, we will put equals. Okay, we cannot do that for angle mates. My bad. What we should do is A is 25 degrees. So we will put 25 here and then select the face of the first link and the second link. So now it has moved in a different directions, unlike as shown in the figure, it needs to be downwards. So what you can do is you can see this flip mate angle. Click on the flip. Oh, my bad, not flip mate angle. Here, this direction, flip dimension. So if you click on flip dimension, the mate will change. Now it is in the correct orientation. And the second one is B, which is on the side, like this side. From this side to this side, see, they have given here, there's an extension, and then it says the B is from other side to other side, not this to this. So B is nothing but 130 degrees, 125 degrees. So select this particular face and this, and the angle is 125, right? Once you do that, go to the orientation and see if the orientation is as per the shown image or not. My bad. Let's go to the image. See, as the orientation is towards, it's uh it's not as how it is, so it should be on the other side. So flip the direction, now correct, 125 degrees. Click OK. And the third angle is between this face, the top face. So that is this and this, which is nothing but click angle mate, which is 130 degrees, 135 degrees, my bad. No, 130 degrees. So click here, 130 degrees, and done. Right now it's properly done. To make sure you add equations to this, what you should do is go drop down the mate section, double click on the mate, and then double click on the visible dimension equals global variable A. That's how you add equation to the mate geometry. Now it is completely aligned. See, as you can see here, there's a sigma sign. That's how you add equation to your mates. Okay. Now again, second one is nothing but equals B, right? And the third one is C equals C. Done. Now we have added equations to the mate. Next thing is all we need to do is replicate the blue color part and the green color part. And how do we do that? Copy with mates. Click on copy with mates, select the component, go to the next, and the concentric is the last phase, and coincident is this. That's it. Done. And the next part that has to be copied is blue part. Select the blue part, go to the next option. The concentric, as you can see here, the purple is the previous one. So the new one has to be something similar. So this is the face. And the purple is the previous one, and the new one is this. See, it is now perfect. There is no forward or downward. If in case your model looks like this, my bad. Somehow buried. Let me just go back. Okay. I think C has changed for some reason. Let me just. Okay, give me a minute. Our C has changed for some reason. Let me just correct that. Yeah. Okay, not just the C, or B has also changed. Yeah, now they are proper. Now I'm using copy with mates again. Select the blue pin, go to next, select the center, select, okay, for some reason, whenever I do this, it's changing the dimension. I'm just gonna save this assembly. Instead of copy with mate, since I'm getting an error, I'm just gonna import it. Even I'm unsure. It's been a long time since I took CSWA. So yeah, I'm just gonna place it here. Select the faces. Go to mate. And then they're concentric now. And this has to be coincident with this. Okay, we'll go back to that once we are done with the entire mate thing. And then again, I'm going to copy the same thing over here. This is the concentric and this is the side. Yeah. Our model is now back to the same position. So now everything is done. We have given the mate, we have given the angle. I hope they are still attached. Yeah, A, B, and C. Just gonna make sure it's visible. Yeah, everything is done. Now what's left is assigning this XYZ axis. But before we do that, as you can see here, somehow it's still rotatable, right? But in the image they have given, the plane is parallel to the XY axis. So what we're going to do is first we'll create this global variable. So as you can see here in reference geometry, there is coordinate system. Click on the coordinate system. This allows you to create a coordinate system wherever you want. Since the coordinate system of this particular drawing is at the center of the green part, the top center of the green part, click on this face. Click 1 minute. Okay, we're going to have to draw the sketch. We will create a point here, right? And then exit. Now we are going to create a coordinate system at that particular point instead of the origin. Now let's click on this particular point. And as you can see here, it says x-axis is red, y-axis is green, and z-axis is blue. Now, after creating that, we get x, y, z, and this has to align like this. That's what it says, right? Just a minute. That's what the question says, right? Now, give me a minute. Now, that means the front plane has to be parallel to this particular face. So we'll just add that mate. Go to mate, select the face, and select front plane from here. It has to be parallel. Click OK. Now we can see some distortions in the angle mate. No need to worry about it. All you need to do is, yeah, that's it. Rebuild and it will be saved. As you can see here, okay, we still have some distortions. So we will just go to mate. This is proper, B is proper, only C is varying. So go to C and change the angle direction. Somehow everything is changing. Yeah, now I think it's back. I think it's just the rebuild errors. Even I'm not sure why this is happening, but this shouldn't happen in ideal case. So as you can see here, the model in the given diagram, it represents the actual model that we have created. And we have also created a coordinate system and the faces are parallel to x-axis. XY plane is nothing but front plane. So the last step is completely necessary for you to get the right answer. Now in the question, what they're asking is to find the center of mass of the assembly. Now, how do we measure the center of mass? It's very simple. All you need to do is go to Evaluate tab, click on Mass Properties. In the Mass Properties itself, it will give center of mass. But this center of mass is with respect to the origin. Our origin is somewhere here, but we don't want this origin. We want the newly created coordinate system. As you can see here, this is the coordinate system XYZ, and they're asking us to find the center of mass with respect to that particular coordinate system. So I'll just change it from default to coordinate system. So when I do that, I get a new center of mass. It says X is 348, Y is minus 88.48, and Z is minus 91.40. All we need to do is we need to check if this particular option is available. X is 348.6, which is available. Y is minus 88.48, which is available. And Z is minus 91.40, which is again available. What happens when we saw some distortions, right? What happens when those distortions exist in the model is that, let me just show that. I'll change the orientation of angle C. Okay, now we're done. What happens when these distortions exist is that your center of mass completely changes. Now you see 298, 68, 51. 298, 58, 61 is nowhere available in the option. So your model will behave very differently, and your center of mass completely depends on how your assembly is being made. So you have to make sure your assembly follows the order or follows the image and make sure the angles are same. Only then you will get a proper answer. As you can see here, 348, 88, minus 91. Let's see if this option is right. 348 minus 88 minus 91. So our option is right. And if I do the changes to the equations, ABC, the ABC changes are 30, 115, and 135. We'll do that. Plus 5, 30 minus 10 is 115, and the C is 135, which is plus 5. See, as you can see here, the evaluates 2 is the important one, not the value or equation. So this is 30, 115, and 135. When we do these changes, I think there is a distortion again. This should be downwards. So we'll change this. Right? 30, that is done. And B is again on the other side, not the same. See, even with the same 30, 135, and 115 changes, the orientation is almost similar. It cannot be completely different, right? So this is B is again changing for some reason. You need to change that as well. Just click on flip dimensions, right? And then again, C has to be changed accordingly, right? That's it. Now, see, this is how it should look, as almost similar to the given diagram. And when you go to mass properties to check the center of mass again, let's go to the answer and see if we are right or wrong. It says 327.67, 327.67. Y is minus 98.39, Y is minus 98.39, and Z is minus 102.91, which is as per the assembly that we have made. So this shows that no matter what changes you make to the original assembly, if the orientation and if your coordinate system that you have created is proper, your answer will always be right. So that's the simple thing to maintain so that you can get the proper center of mass. Even in CSWA, they will only ask you to find the center of mass. And the most important thing in an assembly is to create this, where did that go? Is to create the coordinate system. In the reference geometry, the coordinate system option is available. This is very important. You need a simple point here. You can either sketch a point or create a point. It's very simple to create a point as well. And you can assign this point to be the coordinate system. But you need to make sure the way your assembly looks is similar to the given set of drawings. So that's all you need to do. As you saw in this particular test our part modeling answers were exactly the same because the first question was proper. And again, in the assembly, in the first question, we had the entire thing correct. So the second question answers were also followed by the same variations without any plus or minus 1% error. Even with plus or minus 1% error, the plus or minus 1% error only happens because of a system, and it only appears after your decimal point. If you get any variable variations in your answers before the decimal point, you need to go back to the sketches, check your drawings again, make sure everything is proper, every dimension is proper, and you will get the right answers to all your CSWA questions. And make sure you need 70% of the overall marks to pass the CSWA examinations. And once you do, you are all set for the next step, that's CSWP. And in the same PDF that you will download from the website, there will be helpful sites, all the resources, YouTube channel for SolidWorks, where there will be tips and tricks and also some guidance of for CSWA exam. Make sure you take that. Make sure you give the SolidWorks certification training exam in the virtual tester software. Prepare well, and yep, you're all set for CSWA. So that was everything about the CSWA certification exam. If you have any questions,
Sir, I have more one question.
yes.
Sir, I am not. I have no question for this drawing. I have question the shell. Bradley, is true that I made the shell pocket to using the shell. If you give me the permission, I want to share my screen.
Yes,
Then I.
definitely. Definitely, yeah, please.
Okay, 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 sir. Audio. Sorry,
I think let me just show that as well.
my screen not working. He said will be able to contribute screen.
Hassan, just request for the present, request to present your slide.
Yeah, yeah.
Yes, sorry. Sir, the screen share is not working. Oh, no. Hope you. Is my screen is show with you?
No.
Shit. Uh,
At the bottom of your screen, you can see the option share, right?
yes.
Yeah.
Share
Click on that
screen.
share and ask for the access to share.
Access to share. But here show the Windows and entire screen.
Yeah. So which window you are going to share? You want to share which window?
Share
Set
the
box.
entire window. You can change the apps later.
Okay, yes. But I click enter screen but not its work.
Click on share and then select the first option, that is screen, entire screen, and then click on share. Yeah, we can see your screen. Yes. 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 So Hassan, as you can see here, that's an unwanted shell. So need to again do the cut extrusion to remove that particular thing. Am I audible?
Yeah. I guess he
Hassan?
has muted his speaker.
Oh, okay. Hassan, can you hear me? Hello? Hassan?
Yes, I hear you now.
Uh, So are you still sharing the screen? Okay, I'm just going to show, I understand the doubt. I'll just share my screen once more and then clear that. Yeah, so what you did was partially right. But the thing is, when you do that, see, what you did was you applied multiple thickness shell. What happens is, see, I'm gonna just select some random digit 30. I'm just gonna go with 12, whatever it is, 30, 25. I think it was 25, one which is gave. So I'm gonna select these edges. So what happens is, uh, just gonna unsuppress the shell. So now what happens here is here there is an unwanted shell, right? We don't want that. So you're going to have to create one more cut extrusion option. And one more thing is the distance between, I'm just going to go to the top section. So in the exam, in the question, what they have given is the shell has to be at a distance of 12 mm from the back side, right? But in this way, what happens is the distance between this and this is not 12 mm, but it's more than 12 mm. It's 25. So you need to create one more thickness, cut extrude command to remove the additional 13 mm. So now what happens is, yes, it's true, but it creates a confusion in the users, especially in the fresh users, right? So people start thinking that whatever they have done is now correct. That is the only thing, and they will forget about this particular region and this region, which is not exactly 12 mm from the backside. So that is why if you use shell, you need to create two more cuts anyway. I'm not saying it's wrong, but it is right. But what happens is if you directly go with the cut command, you get to know you can do the entire thing using simple thing. For CSWA, shell is actually kind of a advanced command, especially for fresh users who are new to SolidWorks. Using shell or understanding how shell works, especially multi-thickness shell works, is a little complicated. So the aim of CSWA is to create the entire model using simple commands like sketch, offset sketch, or even convert entities and cut extrude, revolve cut, all these things. So yes, in a way, whatever you showed is partially right. But when it comes to the question, these are the things, like these are the cut things, there is no extrusion, additional extrusion here, as we saw from this particular thing. I'm just going to show it again. See, this is not there, and the dimension of the shell. So these are the things that you need to consider. So that's why I did not show the shell command, but shell command will be helpful in CSWP, where there will be questions. There will be a separate set of section completely aimed at shell commands, multi-shell thickness, and everything. So for CSWA users, you don't have to, if you don't want to, you don't have to worry about the shell command. But if you use shell command, again, you have to carry out two more additional cut extrudes to get the specified dimension or the model.
Oh, yes. Thank you. Now my doubt is gone. Thanks for the beautiful answer. Thank you very much.
No problem. Yeah. Anybody else have any other questions? Feel free to ask or reach out to me at any time. CSWA is very simple. Trust me, you don't even need 3 hours. If you properly prepare for the syllabus, or if you know all the tools or everything, you can finish the exam within 2 hours or so. So no need to worry. Don't worry about the exam. It's very simple. All you need to know is simple tools like boss extrude, cut extrude, revolve, and revolve cut. That's it. And anyways, you'll know the sketch tools. So forget about all the complex tools. Just focus on simple things. Use simple things. Get the model. Get the design. And even in assembly, you don't need to know about multiple advanced mates. All you need to know is simple mates, angle mates, concentric, coincidence, and that's it. You will be set for CSWA. Okay. When do we use these options when mirroring of features? Bodies to mirror, faces to mirror, surface to mirror. Okay. The simple answer is this is not a CSWA question. So Edwin, the simple answer is Bodies to mirror comes into picture when you're designing multi-body system in your part modeling, and you want to create a pattern or a mirror object of a particular body, not a feature. Let me check if I have any model. I'm just going back. Give me a minute. I don't have any. Okay, I can't show any examples at the moment, but when you want to use bodies to mirror, you have to have multiple bodies in your system, or okay, let me just show with a simple example, you know. So as you can see here, I'm going to create a body here and extrude it for, let's say 20 mm, right? Now I want to create, so now if there is a feature in context with this body, then you can use mirror to feature. But if it's just one body and I want to mirror it with respect to front plane, I cannot use features because it will give an error. Right? See, there is no body, there is no feature mirror because the feature is not able to mirror because there's no connecting feature or connecting body. So in this case, you have to use bodies, not features. My bad. Okay, since there's only one plane or maybe one body, I don't think I'm getting that. Just gonna create this. Instead of features, I'm gonna select the faces. And when I do that, it's still gonna give me error because there's no connecting bodies. So I'll just show what happens when there's another body. So now there's a connecting body, and I'm just gonna change this. My bad. 1 minute. Give me a minute. Go to top view. So now I have created something here. And what I want is to create the feature of that and this and this as well. Now what happens is the feature, the mirror that I'm going to get. Wait, something is wrong though. I'll first mirror the actual thing. Now you can see here the feature is being mirrored. And then in the next mirror, that's the base thing. This is the base which is connecting the two, the features. The next is, I'm sorry, the face is front. And then I'm going to select this and this. Now, as you can see here, the features are being mirrored, not the body. But for some reason, I'm not able to mirror the body. I don't know why though. Oh yeah, here it is. My bad. So in the next, now we saw features to mirror, and in the next, I'm gonna select the right plane. The body has nothing to do with the mirroring body, and in bodies, I'll select this entire body. As you can see here, when I do that, 1 minute, I need to uncheck the merge solids because that's not gonna make any sense because these two bodies are not being connected by anything. When I click on OK, as you can see here, there are two bodies now. Could have done that here as well. I forgot to check that option, my bad. So yeah, here I don't have any body here, my bad. See, as you can see here, the body feature itself is being suppressed for some reason. Anyways, you use body mirror only when you want to create a separately the same body, but in a different side of the plane. That's when you create bodies to feature. And feature mirror is something that you want. Let's say you have, you have a structure like this, symmetrical structure, and you want to create this feature on this side as well. And that's when you use features to mirror, right? See, as you can see here, you have now created a feature, not a body. The feature is being replicated with respect to the front plane. And surfaces to mirror is being used in a surface environment, not in a part environment. Let's say you have just similar to the body mirror. Let's say there is a face missing here or something like that. You can select this face to be mirrored on this side. That's how you use the body, face, and uh, feature mirror. That's the difference between all these things. Hope that's answered. Oh yeah, suggestions for getting free CSWA vouchers. Keep an eye out for in the SolidWorks forum. That is 3D Experience EDU platform, SolidWorks User Group Networks. You're already following Hyderabad SWAG, and recently there was world's biggest certification event from Islamabad SWAG. So SWAGN conducts events in collaboration with 3D Experience platform, 3D Experience EDU, and they will. If you keep an eye out on the platform and the forum, you will be notified when there's an event, when they will give out free CSWA vouchers. One of the best ways is to follow Swagans and the 3D Experience EDU community. You just share the community. Any other questions? Feel free to ask any questions, guys. Yes, Mohammed Jan. I'm just going to share the 3D Experience community in the chat. Keep an eye out here. You're already following Swogan, so no need to worry on that part. Keep an eye out in the 3D Experience CTO students platform. They will share multiple things. You can even ask any questions or doubts you have, and feel free to interact with other students. Any other questions, guys?
Looks like there aren't any questions from the participants. Otherwise, great session, Prasad.
Okay, in case if you come across any other questions in the future, feel free to reach out to me on LinkedIn. I'm just going to share my LinkedIn profile link in the chat. Feel free to reach out to me at any point if you have any doubts on how to use a feature in SolidWorks or how to.
Hello, sir. I have a question. Am I audible?
If you have any doubts, feel free to reach out to me on LinkedIn. Is there any question? I can see Mohammed Zain said something, but I did not hear it properly.
Hello. I have a question.
Yeah, can you please speak up? I'm not able to hear you properly.
Am I audible now? Clearly?
Yes, slightly, yes.
When we start exam, we have a different variant of SolidWorks. That's project I have at 2022. When we import files, there is a Hangout SolidWorks. So it is required to latest version of SolidWorks we use 2024 2025. Which version of SolidWorks is best for CSWA exam?
I'm sorry, Mohammed. I could not hear you properly. Your voice is very low, and there was a background noise as well. Can you please type your question in the chat by any chance?
I
Yes. Okay, the question is, so I have 2022 version of SolidWorks. When I import files, it takes time and hangs and shows bugs. So which version I use to give CSWA exam? The one you're good to go with any version about 2018 actually. If I mean, if your SolidWorks version is 2022, that's totally fine. But I'm not sure why it's showing bugs for. So check once again, because the sample exam models or the ones which are available online from the SolidWorks website all have license of 2018, I guess. So they will even mention that. Let me just go to the exam thing. And when you're taking the exam, it says in the notification what version of SolidWorks you should have. I believe it's 2018 and above or 2015 and above. I'm not sure, but it's definitely not 2020 and above, 22 and above, because the exams have been it's being taken by many people on a number of occasions from multiple users with access to previous SolidWorks versions. So you don't need to worry about that. I can't remember the version, but it's definitely not 2022. So if you have to SolidWorks 2018 and above, you're all good to go to take the exam. You don't need to worry about import errors, because that will not be case. It might be an error from the installation side when you're installing something, but I'm not sure. Unless I know what error it says, it's little difficult to say how to come across the error. But if you have SolidWorks 2018 and above, feel free to take the exam at any time. Uh, Share, if possible, please reach out to me on LinkedIn, Mohammed Zayan, with the actual error report. Take a screenshot of the error, send it to me, and I'll tell you exactly how to resolve that error. Hope this helps.
I believe Mohammed Zain, you don't have problem with the version. I believe it's your laptop or your computers.
Yes, absolutely.
Because I guess you don't have SSD. You in your drive is HDD drive. I guess it's a problem with the drive. The SolidWorks
Yeah.
doesn't work good with the HDD drive, and it hangs a lot. I've experienced that with my friend's laptop. It might be quite difficult writing even CSWA exam for HDD drive laptop. I guess you have to change your drive. Switch to as a SSD drive. It'd be better. You can write any kind of exam. So I believe HDD drive is the main problem.
Okay, thank you, sir. I have a SSD of 1 terabyte and 16 GB of RAM in my laptop system.
HDD. You have only HDD, no SSD.
Okay, thank you.
Okay.
Thank you everyone for an amazing audience. Thank you, Syed, for inviting me here today to be the presenter for the CSWA session, and it was truly amazing, and it was fun for me as well because took the sample exam after a long time, I think 4 years or something. It was really fun. Thank you very much once again, everyone. And if you have any questions or problems in SolidWorks, if you have any doubts, feel free to reach out to me at any time. Thank you once again.
Wonderful session, Prasad. Great initiation and approach. Awesome explanation, by the way. Gotta say, I learned some new tricks today. Even after becoming CSWE, I think I saw a lot to learn from you guys. Must say, explanation was detailed and very good. I believe everyone who has participated today can clear their CSWA exam after watching this session, because this session covered everything, every feature and every similar exercises, everything all together, must say. So if anyone, yeah, I will share the recording on YouTube and provide its link on the LinkedIn through a post today or tomorrow or by the afternoon or the evening. If possible, I will do it today by end of the night. Okay. And anything else? If you have any questions, drop in the chat or you can unmute your speaker. I guess there are no questions. Shall we end the meeting then, Prasad?
Yes, absolutely, Syed. Thank you very much once again. Thank you all for participating today, and see you all in the next session of Hyderabad SolidWorks User Group. Looking forward to the next session, Syed.
Thank you so much. Thank you so much for being here, Prasad. Thank you so much. Goodbye, everyone, then. I'll post
Goodbye.
the
Have a great
recording.
day.